Yes. Okay. Hello everyone. I am Sumit Kumar. I am PMR Research Scholar at IIT Dhanbad. In this sessions, I am taking the course of Geotechnical Engineering 2, in which we are studying the various aspects of the application of the parts which we already covered through Geotechnical Engineering 1 sessions. Okay. So we have gone through the various contents throughout our lectures. Okay. So first of all, I want to add some points before going into the today's session. And the important point you need to be concerned about during this session is that this session is going to be held for 2 hours from 3 to 5. This is the 11th sessions of this series, and as per the previous schedule, we have one more sessions next week on the next Saturday, which will be the concluding session. But if required, I can take one more sessions in the subsequent week. If anyone have any doubt remains after that as well. But as per schedule, it will be ended, concluded in the next session. Okay, so some of the important point like this session is going to be recorded and will be shared with you in the due course of time. After the session get over, the session will be loaded on the YouTube and the link will be shared with you. I have seen that several of you are got engaged over there in the discussions, and you have seen the videos over there apart from this live class. So um, I will say that if any doubts remains from there, you can ask me at this platform at any point of time. And the presentation file which I am showing over here during the discussion will also be shared with you by the NPTEL team. The link in the of the Google Drive in which the file has been shared is already shared. So the files will be there, and those files can be accessed by you at any point of time. Okay. So one more information I would like to add in, like if at any point of time due to network issue, if I got disconnected, please we remain in the meeting. I will rejoin and start the session from there only. It haven't happened from the last 10 sessions, so we hope that it will not going to take place today as well. But this is the general guidelines I would like to add on. Okay. So, before starting, I will say that if any doubt is there, you can raise hand. And apart from that, I would like to add on the people who are not over here at live and watching it on YouTube can also ask the doubts in over there as well in comment section or in practice in the next session which is going to held on. Okay, so first of all I will share the presentation, then I will first of all give a small perspective that what we have discussed uh, up to now, and then we will go ahead. So I will take the theoretical aspects mostly, and the most of the numerical problems which has been discussed during this week. The some of the theoretical aspects which has not been able to cover due to time constant during the last session will also be taken over here. And afterward, we will go with the aspects of this week, that is the slope stability and slope instability, and the problem related to this and the sections which specifically the theoretical aspects and the conceptual aspects, I will say more precisely, will be discussed today, and the practical implementation of those aspects will be taken in the next class. When I say practical implementation, I will say that the problems which could be framed on those concepts and how we will solve those problems will be taken over there. So I will start with the bulkheads and then go ahead. Okay. So first of all, I will share the presentation, then I will add some point over there. Okay, give me a minute before I will share. Okay, so I think so my presentation is visible. Yes, I can also see that. Okay. So the course we are studying during this session is named as Geotechnical Engineering 2. This is the subsequent course of Geotechnical Engineering 1. Basically, the prerequisite for studying this course is the Geotechnical Engineering 1, in which we have read the basic concepts of the geotechnical engineering, which some places also known as soil mechanics or the geotechnical engineering one. And during this sessions, during this geotechnical engineering 2 coursework, we have studied specifically the practical implementation of the basic concepts which we have came across during the geotechnical engineering 1 coursework. And in this course, we have developed the idea, generalize our idea to get how to implement the concepts which we have came across in our basic aspects. Okay, so during this coursework, first of all, we have studied about the shear strength. So we have understood the importance of shear strength, its significance, and its applications. Sorry. We also came across about that how we can find the value of shear strength at a specific section, and what do we mean by shear strength, whether it is the strength of soil, what is the critical sections, how can we implement the critical section, the section through which the soil get failed, the critical combination of stress points through which the failure takes place. We have seen on those points. Apart from that, we also came across the knowledge of how to perform the different tests in order to find the shear strength of soil. So in that regard, we have discussed the direct shear test, triaxial test, vein shear test, and we have gone in that detail as well, and we have understood the analytical as well as graphical interrelation, in which we are able to develop our idea, in which both the way we can able to find the shear strength parameter like C and phi. Specifically, we have seen the triaxial test in also a triaxial test in detail, in which we came across the knowledge about in the triaxial test, the cohesion, mm, and seat and phi could be found in the total stress as well as effective stress approach. We have read undisturbed UU test, that is the undisturbed unconsolidated test, CU test and CD test, and their pros and cons we have came across. Okay. Afterward, we move to the earth pressure theory. Earth pressure theory also we have understood the earth pressure at rest, earth pressure, active earth pressure as well as the passive earth pressure. And during our study, we came to know that how the earth pressure analysis, earth pressure study give a basic idea about the how much the pressure can be acted. In that regard, during the study, we also came to know that how much the depth, unsupported depth, and could be there. So those points we have came across. Okay. Now In these sessions, we are in the today session, we are going to study the slope stability. So first of all, we will start with the slope stability, and okay. So there could be two plan. One is we could start with the slope stability, and another is we can start with the anchored bulkhead, and after, because anchor bulkhead is the sections which has been remain and taken during from the last session. So there could be two idea that we could start with slope stability, and afterward we will move here, or we could start from here and then go on those sections. So okay, I think so we could start with the slope stability, and afterward we will move over here. I think so that will be also a good idea to go with. Okay, so I will start with the slope stability first, and then we will move over here. Okay, so there are some problems also I have mentioned over here. So I will take some of the problem as well, but some of the details problem will be taken in a next class. Okay. So first of all, I will start with the slope stability. Then the sum of the section which has been remained from the last session will be taken then. Okay. See, so we are talking about slope stability. So we came across, I have kept the slope stability content in the two portion. First of all, we will go with the slope stability at approach. Then again, we read the same part with a different perspective, because that will be, you have seen that during this session from starting to this time, our revision sections always kept for the same slide to give the different perspective for the same idea in order to get the concept very easily. So you see, that's not a big deal. Okay. So first of all, we are talking about the slope stability. So we know that when we talk about the slopes, there is a finite slope and there is an infinite slope. Over here, during our study, we are going to first of all take the infinite slope. The finite slope study could also be there, but the problems related to that will I have mentioned over here, but we could go first of all we could skip that part, and we will understood first of all friction circle method. Hmm and what are the value for the infinite slope, because first understanding of infinite slope will be important. After that we could do the analysis on finite slope by the Bishop method, and the many more methods are there, Jambuj method, and so we could go across as a second step on those courses. Okay. Oh, my presentation is not visible, I think so. Okay. If my presentation is not visible, anyone can add on that your presentation is not visible. Okay, not visible. Okay, so I'm talking about the slope stability. So how we are able to achieve, how we are able to keep the stability along the slope will be the concern. Okay, so see, so first of all, we will start with the introduction. Why we need to understand the slope failure. So, anything from the very first class, we have taken that anything we are reading, whether it has significance, whether it has some applications. If not, no need to go with those study. There must be some significance and some applications of the concepts. Otherwise, studying or understanding any concepts have no meaning. So, first of all, the question we ask to ourselves that why we need to understand the slope failure. Because You have seen in our day-to-day life, there is a we have came across there is a failure takes place. The slow failure takes place along the sections which lead to the great disasters. I will also show some of the images which will represent the failures of slope. So the factor of safety we need to understand that we need to understand that after this much stress, the failure takes place along the slope because the terrain across the globe, across if we remove the word across the globe, we consider only our country also. We came to understand that there are the several regions where the slopes are there and the construction over there may be sometime in danger, whether those are the road projects or maybe some projects related to buildings. So those aspects we need to understand and taken understand and to be need to be taken care of. So see, this is what we see. This is a slope and you see that the failures takes place and the soils move from upward to the downward direction and there is a habitation over there downward which is submerged due to the failure of slopes over there, the soil over there get move in this direction resulting into the submergence of this area. So this will create a problem for the people who are residing over there. This will also sometimes lead to the loss of life as well. So it's our duty. So before the construction at any places, the whether the slope behind it will be the stabilized or not, whether it needed to be stabilized or not, need to be taken care of before the construction of any habitations, construction of any building structure, beside or ahead of that. Okay, okay. Now. See, these are the some of the more slopes failures could be seen. See, there are the so much sharp slopes are there. If some construction are there, this will. If some construction are there beyond that, the failure will result in the loss of life and property at that cross section. So those things we need to understand. Now see. You can find that in the last picture there are the slopes all across and in between the constructions is there. But if the failure takes place at any sections which surrounds this will lead to the great disaster for the people residing at that section. So those things need to be understood by every person in order that why we need to understand the slope, why we need to understand the slope analysis, stability of slope analysis. Okay. Again, there is a different Indian overall topographical image has been shown, so we can see there are the several slopes could be seen over here. Some are the very steep and very vast slopes also presented over here. Okay. Now, now we come to the sections where we came across our develop our understanding regarding the slope and its necessity. Okay, give me a minute. I will take some water. Okay. See, now the question is there the slope and its necessity. So An exposed ground surface that stand at an angle B not that is beta I will tell, with the horizontal is called slope. So in general what in the very basic understanding we can see that from the diagram as well the facing slope has been seen which make an angle beta with the horizontal. So the beta will be the slope angle which has been made over there with the horizontal direction, and the constructions takes place along those slopes as well. The constructions of highway and railway embankment, earth dams, slips and canals could be there in order to provide the proper communication as well as protections from the different section protection of people from the different calamities maybe. Okay, now we see we have came across, we have already told that there are the maybe infinite slopes and finite slopes. The slopes could be infinite or finite because if the section is confined when I say it has a small section. So if there is small section, the slope is created over there is a finite. But if a section is very wide across, so the infinite slope would be there. Okay. So when we talk about the infinite slopes, so they have been the dimensions that extend over the great distance, as I said earlier. In theoretical aspects, also we see that the that dimensions will be very large, and the soil mass is inclined to the horizontal. So we see first of all we have understood about the slopes. We have seen, we have understood, we have tell that the beta which angle make with the horizontal will be the slope angle. But when we talk about the infinite slopes, so that angle is very less because maybe high, but if it is a high, the slopes may be finite at some point of time. So we will came across as we proceed. But when we talk about the infinite slope, so they have the dimension that extend over the great distance. Because if the distance is not too large, the slope could not to be said to be infinite. Because if it has at the finite length, so it will be maybe the finite slope at some point time or the other. Okay. Now when talk about the finite slope is that with a base and a top surface. Because at the finite sections then we can identify that finite section, and the height is also limited for that, and the inclined face of the earth damming backments excavations and the are the one some of the finite slopes examples in a real estate. Okay. Now see, when we talk about the slopes, okay, so the slopes which could be the man-made or and as well as a natural, it has very well understood that the images, the pictures which I have shown recently, you see, so those slopes are the natural slopes, which has been created by nature. As I have shown over there that the habitations, the peoples, the constructions which has been created over there in between the different slopes. So those slopes needs to be studied, understood whether that slopes has been there from the very vast period of time where they have the sufficient stable strength, or we need to stabilize in order to create some construction over there. So those analysis need to be done by the geotechnical experts in order to convey whether those locations, the construction at those locations will be safe in future as well. So those are the natural slopes which have been shown in the recent slides. Okay, now we talk about the man-made. So when some construction takes place over there, the cutting and filling takes place lead to the formation of some slopes will be said to be man-made slope. But when you analyze, you find that the man-made slope might be finite at the maximum aspect of time, as the infinite slope has been observed. Natural slopes could be in infinite as well as finite, but the man-made slopes are mostly finite in nature. If it has been not modified to the previous slopes which would be there. Okay. Now, we have a question that what is the reason why we are interested in understanding slopes? There must be some outcomes which we want to achieve. That's why we are coming across these aspects. Yes, the sum of the points which we want to understand with the help of the understanding of slopes is like the failure of natural slopes, landslides, and the man-made slopes have resulted in the much loss of life of people and destructions, as it has been shown from the pictorial representation we have seen that during the failures of slopes there is habitation over there is a large number of construction over there, but as the failure of slopes takes place, beside that the soils fall down and get completely submerged. That sections leads to the create a great destruction. The people residing over there maybe submerged in those hazards. So that is a very disastrous aspects. So for that we need to understood. Afterward, we will suggest the construction activity over there should be there. Whether the stabilization needed because the slope could be stabilized with the various aspects of the different techniques which are already there, or the new techniques could be achieved in order to make our aspects very much clear. Okay, so the safety of the natural slopes needed to be checked by the civil engineers. Slope stability analysis consists of determining and comparing the shear stress developing along the potential of the surface with the shear strength of the soil, because we already know, we have a very well knowledge about this fact while studying the shear strength. I have taken these aspects very much clearly, that the failure takes place at the critical combination, the section over there, the shear stress is greater than or greater than the shear strength. At that sections the failure takes place. So that analysis need to be understood along the slope in order to justify that this much strength is there, this much stress is developed. If the developed stress is less than the strength of the shear strength of the soil at that section, the failure doesn't take place. But we need to understood that in what circumstances, in which conditions, the shear stress at that section could surpass the shear strength of the soil, and accordingly we will provide specific stability analysis in order to protect the slope and increase the factor of safety in one way or the other. Because the fact, when I talk about the factor of safety, the factor of safety is the shear strength divided by the shear stress which is going to be developed. So the stress developed will be less and the strength is more. So the factor of safety is greater than one. More the factor of safety, less the chances of damage, and we always take the factor of safety in order to provide the protection against the failure during the adverse conditions. Okay, now the attention has to be paid on the geology, surface drainage, groundwater, and the shear strength of soil in accessing the slope stability. These are the some of the crucial point which need to be taken care of by the geotechnical experts in order to convey their understanding regarding the slopes. So, in a real sense, one can say that the understanding of slopes will be developed in some way or the other. Okay. Okay, so now we move to the slope failure mechanism, by which mechanism the slope failures get triggered. Okay, so there must be some reason due to which the slope failure takes place. Okay, give me a minute. So slope failures uh, triggers triggering mechanism when we say, so we came across in by the several news articles, several times we have seen that some flood come, or maybe due to heavy rainfall the failures takes place. Specifically when we during the rainy season we came across the several news articles in which we have came across in our day-to-day in news articles, like the failures takes place at that sections, at those sections due to the heavy to heavy rainfall. Specifically, when we talk about the regions, hilly regions like Uttarakhand, or maybe some section in Himachal. In those hilly regions, we came across with those like due to the heavy rainfall, the failure of slopes takes place. So during the rainy season, the change in the stress of the soil will takes place due to the change in the water table, because we know that the water is the one of the reason to be changed in the effective stress, because the pore water pressure get changed due to increase in the water table. Pore water pressure get increased, so the effective stress got reduced, and if the effective stress get reduced, the shear strength will also be hampered, because shear strength is nothing but S equal to C plus sigma dash, and 5 year sigma dash is the effective stress. So if the effective stress get reduced, the shear strength at the specific section also get reduced. So the if the stress which has been acting over there will remain same at that point of time as well, will result in the failure of the soil at that section. So the intense rainfall is one of the triggering mechanism, and the change in the water level takes place only due to the rainfall only, or maybe some other reason like some water facility, there may be some river or something which is filled with water, resulting in the increase in the groundwater table, maybe result in the reduction in the effective stress, concluding in increase in the poor water pressure, resulting in decrease in the effective stress and lead to the slow failures. Okay. Apart from that, when we talk about seepage water flow, the seepage water flow also takes place during the rainy season, because of the accommodation of water at the specific section, maybe due to rain or maybe due to some water storage body will lead to the seepage water flow, and the seepage water flow also lead to the chances of failure along the slopes. The volcanic eruption may be also a reason, but in our country, if you talk about, there is a no active volcano in a real sense, which lead to the failure of slopes. So this point could be eradicated if we talk about the India perspective, but for a global perspective, this is also a reason. And the earthquake shaking is also one of the greatest reason. We have seen that during the earthquake the plates movement takes place, resulting in, because slopes is you see, if we are standing on a plain sections, we are stable, but if we are climbing on a slope upward, or maybe moving downward, we are not in a stable directions. If we are standing straight, someone push us, we could sustain ourselves, we could go frontward but not fall down. But if we are stand on a slopes, maybe moving downward direction or maybe moving upward direction, if someone push us, with the same amount of force which they have pushed when we have extended. There is a maximum chance that we lose our balance and maybe fallen down if we are standing on the slopes, irrespective of when we are standing on the flat section. So, in the same way, if the sloping ground, if the slopes are of the larger extent, the failure, the chances of failure is very high as at that section as compared to other section. Okay. Okay. Now, the human activity is also one of the reasons. So, that region could be inaugurated in a different way. Like if some vegetation is there, and that vegetation also lead to sustain, bind up the soils and over there and protect the slope in one way or the other, but due to the development activity, if we ignore those aspects and reduce the vegetation, so the sustainable development is equally important, but if that hamper the stability of that place, may lead the one of the region which can trigger the failure of slopes at that section. Now, see the causes of slope failure. Okay, so we are reading over here again in the next section as well. We are taking these points in a different perspective as well. So first of all, see the causes of slope failure. So the first is the erosion. Erosion is one of the major reasons. Erosion takes place in which the soils move downward from the weakest sections, and why this erosion takes place? Wind, flowing water. Flowing water is the biggest reason which lead to the failure of slopes due to erosion. So flowing water cause erosion of the top surface of the slope and make the slope steep and thereby increase the tangential component of the driving force. You know that if the slope is steep, the force due to its own weight is too high, which lead its failure, which lead its movement in the downward direction and can lead the failure of the slope at that section. So, that point must be very much clear in everyone's mind. Now, see the steady seepage is the second point. When we talk about the steady seepage, the seepage force in the sloping directions, the seepage force in the sloping direction and the gravity forces and make the slope susceptible to instability. The pore water pressure decrease and the shear strength. The condition is critical for the downward slope. So see, what when we see steady seepage, when a seepage force in a sloping direction added to the gravity forces make the slope susceptible to the instability because it will add on to the gravity forces the in a sloping direction. So the pore water pressure decreases and the shear strength. The condition is critical for the downstream slopes. So that is also one of the causes of the slope failure. The third one is the sudden drawdown. In this case, there is a reversal in the direction of flow and result in the instability of the side slope due to the sudden drawdown of the shear stress are more due to the saturated unit weight, while the shearing resistance decreases due to the pore water pressure that does not dissipate quickly. The one of the biggest reason which is also mentioned earlier as well at the different point of time, that is the rainfall. The rainfall is one of the reason. The long period of rainfall saturate, soften and erode the soil. Water enters into the existing crack and may weaken the underlying soil layer, leading to the failure. For example, the mudslides takes place in a sloping region. Okay, now see, the sum of the more causes, that is the earthquake. Earthquake is one of the reason, and it has been discussed as well that it include the dynamic shear force. In addition, it will add on the dynamic shear force at that section. In addition, there is a sudden build-up of the pore water pressure that reduces the ability of the shear strength because due to shaking, the the pore water pressure may be increased, which will be resulting in the ultimately result in the um, decrease of the effective stress. Okay, okay. So the earthquake is one of the major reason in that way. Okay, now see the external loading. When we talk about the external loading, the additional load places on the top of the slope increases the gravitational forces that may cause the slope to fail because that is not that is the basically the one of the case, and it is not going to happen frequently, but this is also one of the reasons which lead to the failure of slopes. Now the construction activity which already add on in the when we say the human activity which lead to the failure of slope. So the construction activity at the toe of the slope, the excavation at the bottom of the sloping surface will make the slope steep and thereby increasing the gravitational forces which may result in the slope failure. So this is one of the aspects which one need to understand before going into those consideration of the causes which lead to the failure of slopes. Okay, now see, when we talk about the slopes, so we need to understand some of the points and what are the name of that and how we convey those terms. So first of all, let's see those terms and then we will move ahead one by one. Now, so the first of all, you see over here, the starting from the point B. The point B is said to be the crest of the slope. Now move along that orange line only and see the crest of the slope has been visible. Then move to the point B and move along the slope from B to A. The slope has been represented, which make an angle beta with the horizontal, and the point A, the lowermost point, is the toe of the slope. Now move in the vertical directions from vertical means in the above direction, not perpendicular direction I am telling about. And from B and from A, the angle made by that is the theta, and the point where this point meet is the center of the rotation that has been represented by O. Now the slip or the failure surface is also presented over there, and the sliding mass has been also seen. So the key component of the slopes which one came across while understanding the failure of the slopes. Now, see the sleep or the failure zone. So one by one we will see the sleep and the failure zone. So see the picture, the dotted line, it has been shown by the dotted line, the sleep or the failure surface. So first of all, we will understand the definition of that term. So it is a thin zone of soil that reaches a critical state or the residual state and result in the movement of upper soil mass. So this is the critical zone through which the failure could take place. Okay, well clear. Now the slip plane or the failure plane or the slip surface or the failure surface. So what is this? It is the surface of sliding. It is the surface of sliding. Now we talk about the sliding mass. We have seen the horizontal line and the mass between that is the sliding mass. So see, the sliding mass has been seen. It has been between the point AB and the slip or the failure surface. So from this picture, one can easily see. that the slip or the failure surface has been created and the sliding mass also has been presented over there. So the sliding mass is that mass. So this is the mass of the soil within the slip plane and the ground surface, that is the sliding mass. Now the slope angle we have understood very well. So it is the angle of inclination slope with the horizontal which has been represented by beta earlier. Now at this point of time we have to see what has been shown. So it has been beta only. Okay, you see the angle of slope with the horizontal is beta, which has been represented over here. Okay, okay. Now the slope angle is sometimes referred to as a ratio. For example, okay, two horizontal, one vertical. Maybe sometime you see three horizontal, two vertical. So this in this way, the slope angle is sometimes mentioned. It is not always mentioned in the beta like in this much angle degree. And what do we mean that if over here the two horizontal, one vertical means if it move it 2 meter in the horizontal direction, 1 meter in the vertical direction, and if we take one horizontal, one vertical, so that is the 45 degree. Beta is 45 degree in that case, because whatever there you can convert into the tan angle, like the over here the tan theta is 1 by 2, so theta equal to tan inverse 1 by 2, and we are able to find the value of that component. Okay, now see. Now we talk about the type of failure. So the failure could be broadly classified into three types. First one is the phase failure, second one is the toe failure and phase failure, and second one is the toe failure, and third one is the base failure. When we talk about the phase failure, that is the slope, so we will take this one by one in detail. So first of all, see the phase slope failure. The phase slope failure has been represented over here. This type of failure occurs when the slope angle is large and when the soil at the toe portion is strong. If the soil at the toe portion is strong, like the at point A is strong, and in that cases, failure takes place from this section and the failure arc has been represented over there. The failure mass is also represented like between the sloping zone and the failure arc. So the failure takes place from this section in this regard. When we talk about the toe failure, in this case, the failure surface passes through the toe, and this occur once only when the slope is steep and homogeneous, and the soil at the toe section is the weakest. That's why the failure takes place from this section. Now, when we talk about the base failure, in this case, the failure surface passes through the base surface passes through below the toe, and this is generally occurs when the soil below the toe is relatively weak and soft. So this type of failure takes place. Now we will move to analysis. Before that, we will take a small break of 5 minutes. So afterward, we will again start our session. Up to that, we will take a very small break and we will move afterward. Okay, so take a 5 minute break. Okay, we will meet in 5 minutes. Welcome back, everyone. So we have understood the three type of failures like surface failure, base failure, and toe failure, and how it will taking place. We got to know and we have understood those aspects regarding the problems which has been created due to which those failures takes place. Now we will move to the analysis part. At how the analysis takes place, how we will able to find the factor of safety. So first of all, the factor of safety of a slope is defined as the ratio of average shear strength of a soil to the average shear stress. It has been stated as well by me that the strength is that much which the maximum that section could sustain, and the shear stress is the value of stress which has been acted at a specific point of time on that section on which the maximum strength has already mentioned. Okay, now. Yes, I think so. Now, so the ratio of those terms will result in the factor of safety. The strength is above and the stress which has been applied will be below, and the ratio of those two terms will resulting in the value of the factor of safety at that section. Now, the shear strength of the soil is given by tau F equal to C plus sigma tan phi, and where C is the cohesion and phi is the angle of internal friction, sigma is the normal stress, and on the potential failure surface. Similarly, the mobilized shear strength is given as tau d equal to CD plus sigma tan phi d, where CD and phi d are the cohesion and angle of internal friction developed along the potential failure surface, and the factor of safety in that case becomes C plus sigma tan phi divided by CD plus sigma tan phi d. So, in this regard, we will state our result. Now, see, the factor of safety with respect to cohesion will be C by CD, where CD is the mobilized cohesion, and when we talk about ultimate phi, the F phi is equal to tan phi by tan phi d. So when we say FC equal to F5, the C by CD equal to tan phi by tan phi d. So Fs equal to Fc equal to F5 when Fs equal to 1, then the slope is said to be state of failure, because when the Fs equal to 1, it is the critical state. Just increase in the stress by a unit will result, not by unit, by the decimal unit also result in the failure of the surface, slope surface. Now, first of all, see the finite element, finite slope analysis. So we will read the that aspects first, then we will move ahead. So a finite slope is one with a base and a top surface, the height being limited because it is finite height, finite surface. So finite slope, so the height will be known to you because it is a high, infinite, it is a high length, and from where it start, from where it end, we will not able to identify very clearly. So we could not state that and this much height would be there. But in this case, the height being limited, and the inclined faces of the earth dam, embankment, excavation, and the like are all the finite slopes. Investigations of stability of the finite slopes involve the following steps. First one is the assuming a possible slip surface. Second is the studying the equation of forces acting on this surface. Third is the repeating the process and sorry, repeating the processes until the worst slip surface, that is the one with the minimum margin of safety, is not found. And afterward, because this is a trial and error process when we studying the finite element, finite slopes. So analysis methods some could be taken care of is like the Swedish circle method, arc method, method of slices, and the standard methods. Apart from that, the Bishop method, Bishop simplified method, Taylor stability number are the some of the approaches which has been could be taken care of. Now the first of course is the Swedish circle method of slices for a cohesive frictional soil like the C5 soil. So the adopted for the general soils which have a combined grain of C and phi soils, uh, C and phi soils, the C5 soils, the undrained strength envelope shown that both C5 value, the total stress analysis can be adopted in this regard. So you see over here the theta has already found to us a point A and point B. The toe point is like A has been represented, and the free body diagram is also of the slices has been represented in this picture. Now the first procedure is to draw the slope to the scale. A tri-slip circle such as the AB with the radius R is drawn from center of rotation or divide the soil masses of the above slip circle into the convenient number of slices more than 5 preferred, and determine the area of each slices as A1, A2 and AN, whatever the number we have divided, where A will be B into Z. So you see the free body diagram over there, the B has been shown and Z has been shown. So the slice should be look like that. So B to Z will be the area. So A1 to AN has been found. Now determine the total weight W of external load. How we able to find V into Z area has been known. We multiply with the gamma, that is the kilonewton per meter cube. So the kilonewton per meter we have load has been found for that section. So the gamma is the unit weight, B is the width of the slice, and Z is the height of the slice. In that way, we are able to find A1, A2, A3, AN. Now, the reaction R1 and R2 on the slides or the slices are assumed equal and therefore do not have any effect on stability. Okay. The reaction which has been shown R1 and R2 from the both direction have assumed to be same, so both cancel each other. Now the weight W of the slice is set off at the base of the slice and the direction of its normal component n, which has been shown in the picture as well over here, and the tangential component t also represented are drawn in the complete vector triangle, where now n become w cos delta and t become w sin delta, which has been the function of w, and w has been found by multiplying area with the gamma. So the value of n and t are scaled off for the each of the slices, and the value of n and t are tabulated and summarized up as shown in the table given in the subsequent slides. The factor of safety calculated the sliding moment, that is R into summation of T, that is the reckoned positive if clockwise, and restoring moment like R into C into R into theta plus summation of N tan phi. So the factor of safety relation become CR theta plus summation of N tan phi by summation of T. So you can see over here. So first of all, we write the slice number, preferably more than 5. Then we calculate the area as B into Z. What is B, what is Z has been already understood. B is the width of one slices, Z is the height of that slices. So the area has been calculated, multiplied by gamma, the weight W calculated because we take the unit thickness. So B into Z into 1 into gamma is the weight in the kilonewton. Now n equal to W cos delta, delta has been shown in the previous slide, and T equal to W sin delta has been found, summation of n and summation of n T is created. Then to find the factor of safety, we use C into C the cohesion, R into theta, theta equal to LR, L equal to R theta, so L by R, and plus summation of n has been found and summation of t has been found, so we are able to calculate the factor of safety. And now afterwards repeat at step 2 to 9 by considering the various trial slip surface. Okay, this has been created by taking the one slip surface, and we have already said this is a trial and error method. And afterward calculate the factor of safety again for the each slip circle, and the slip circle with the minimum factor of safety, if the factor of safety is found to be 1, so that has been said to be the critical circle which has been found. So this is the trial and error process, not very difficult, but it has been lengthy. Okay, now see the Bishop simplified method. Swedish circle method ignores the rotational failures, as we have ignored the reaction R1 R2 over there. So in this method, as the Swedish circle method ignores the rotational failure of each slide but consider overall moment equilibrium conditions. With the in Bishop method, the equilibrium is considered for all the forces at each side, as we see over here. That now we move to the Taylor stability number. So in slope, and the Taylor stability number is widely used in the slope of the component of the self-weight gamma causes the instability of the cohesion contributes to the stability, the maximum height HC, and the slope directional proportional unit cohesion and inversely proportional to unit weight. In addition, HC is also related to the friction angle phi u and the slope angle beta, and this can be expressed as HC equal to Cu by gamma into F function of phi and beta, when the term the function of phi and beta is the dimensionless, then the equation above is the dimensionally balanced in one way or the other. Now Taylor has expressed the function of phi beta as the reciprocal of the dimensionless number, that is the stability number, popularly called Taylor stability number. So f phi beta is 1 by Sn, and Sc equal to C by gamma Sn, Sn equal to C by gamma H into F O S, Sn equal to C by gamma Sc, Sc equal to H into F O S, so Sn equal to C by gamma H into F O S. So these things is Very much clear. Now, now we move to the infinite slopes. Okay, so we move for the infinite slope analysis. So the slope stability for the earthen dam for the different conditions. What are conditions? Okay, I will tell. In finite slopes, a slope stability for earthen dam for different conditions when we are talking about. Hmm. And so in finite slopes have the dimensions that extended over the greater distances, and the soil mass is inclined to the horizontal. If the different strata are present, the strata boundary are assumed to be parallel to the surface. Failure is assumed to occur along a plane parallel to the surface, and when we go ahead, we will able to find the sloping surface has been shown and the angle has been beta, and this has a vary of the infinite length over there. Now, when we take into the analysis, we do the analysis for the cohesionless soil, cohesive soil, and the cohesive frictional soil. So, infinite slope in the cohesionless soil. When we talk about the cohesionless soil, so C is 0, only phi is there. So first of all, consider an infinite slope in a cohesionless soil inclined at an angle to the horizontal, that is beta. Consider an element A, B, C, D of the soil mass, and let the weight of the element be W, and the component W parallel to the slope will be W sine beta, and the perpendicular to the slope n equal to W cos beta. The force that causes slope to slide is T equal to W sine beta, and the force that remains restrain the sliding slope is the sigma tan phi, that is n tan phi, that is the w cos beta tan phi. So the factor of safety against sliding is the resisting force by the sliding force, w cos beta tan phi by w sin beta. So the w and w get cancelled, and ultimately the sin beta by cos beta is tan beta, so the factor of safety becomes the tan phi by tan beta. Okay, very easy. Now, applying the concept of limit equilibrium under the limiting equilibrium Fs equal to 1, so the tan phi equal to tan beta is beta equal to phi. That is the critical combination. So the maximum inclination of the infinite slope in a cohesionless soil for the stability equal to the angle of internal friction of the soil. So whatever the angle of internal friction, that would be the value of beta will be the critical combination for the infinite slope critical conditions. Now, the limiting angle of inclination for the stability of the infinite slopes in a cohesionless soil. You see, the shear stress and normal stress are plotted on the vertical and horizontal axis respectively, and the unstable slopes has been shown, limiting condition has been shown. Limiting condition is the Mohr Coulomb strength in Vela, and the stable slopes are which are below, that has been painted by beta. The Mohr Coulomb strength in Vela has been, the limiting condition has been shown as phi. So if the beta is less than phi, the slope is stable. If beta is greater than phi, slope is unstable. If beta is equal to phi, the slope is in the limiting condition at the verge of failure. Okay. If it has been just increased the value of phi, it will result in the unstable slope, that the failure takes place. Okay. Now, see the infinite slope in the pure cohesive soil. So, you see over here as well the cross section in which the L length and the Z height has been represented. The N and T also represented, which act as the W cos beta sin beta, W sin beta and W cos beta respectively. So, see. again over here. The normal stress at the failure surface sigma equal to n by L into 1 and cos beta equal to B by 1. So 1 L equal to B by cos beta, and where W equal to gamma ZB as earliest, and sigma equal to gamma ZB by B into cos square beta. So the gamma Z cos square beta. So sigma n equal to W into cos square beta. Similarly, sigma n ultimately become the value. Now the CH study equal to T by 1 into 1 W sin beta by 1 into 1 W sin beta by B by cos beta. So this will result in the gamma Z sin beta cos beta. So the factor of safety become tau f by tau d as C by gamma Z sin beta cos beta. So factor of safety become C by gamma Z sin beta cos beta. In other way also we know the factor of safety, if we in general we write, and so it become factor of safety equal to C plus gamma Z cos square beta tan phi by gamma Z cos beta sin beta. So we follow the same condition, but in this regard the gamma Z is 0. Okay. Now, as the critical condition Fs equal to 1, Z equal to Cy gamma Z sin beta cos beta, and for the given slope, the Zc is the directly proportional to the cohesion and inversely proportional to the unit width. So you see over here, Cy gamma Z is the dimensionless quantity called the stability number, and which has been represented by Sn, and Sn equal to C by gamma H into FOS we also say, where H into FOS is nothing but HC, which is ZC in real sense. Okay. Now, the infinite slope in the cohesive soil, the ultimate relation which I am talking about, like the C plus gamma Z cos square beta tan phi by gamma Z sin beta cos beta, has been shown over here. In this regard, we are able to find the value of factor of safety, and in the this case as well, we see that the C cohesion is there, so the angle of phi has been going above, and it will create the limiting condition at some point of time. Up to that, it could be stable after as well if the angle is greater than the respective value of beta. Okay. Now we will move to the problems. So first of all, see, the problem has been there, but I will like to skip this and take this in the next section, and I will take the stability of slopes again up to extent before as a revising sections, and then we will close the today's session. Okay. Okay. Before moving to this, we will go with the bulkhead, which has been remained from the last session, and afterward we will come over here. Okay, no problem. So this is the section which has been left during the last session. So understanding bulkheads. So the anchor bulkhead are the retaining wall that are used to prevent the soil erosion and to provide the area suitable for docking. Anchored bulkheads are typically constructed by driving the steel sheet piles into the ground and then anchoring them into the tie-break system. A tie-break system can be made up of steel cables, rods, or stirrups. The anchor bulkheads are used in a variety of applications like the waterfront construction, riverbank stabilization, highway, railway construction, and the land reclamation. Components, when we talk about the components of anchored bulkhead, so the seat piles are the vertical wall that retain the soil. The tie backs are the anchor seat pile to the ground. And when we talk about the vaulter is a horizontal beam that connects the top of the seat pipe. Coping is a cap that protect protect the top of the seat piles from erosion. The gravity bulkhead rely on their own weight to resist the lateral pressure from the soil. Cantilever bulkhead rely on the tieback system to resist the lateral pressure on the soil. Types of anchor bulkhead. There are the two main types of anchor bulkhead, the gravity bulkhead and the cantilever bulkhead. The gravity bulkhead rely on their own weight to resist the lateral pressure from the soil. The gravity bulkhead are typically used in the shallow water application. Cantilever bulkheads rely on the tieback system to resist the lateral pressure from the soil. The cantilever bulkhead typically used in the deep water application. When we talk about the design of the anchor bulkhead, so it depends upon the type of soil, depth of water, height of bulkhead, and the surcharge load of bulkhead. When we talk about the construction of anchor bulkhead, the construction of anchor bulkhead typically involves the sum of the following steps. The steps like the seat piles are driven into the ground, tiebacks are installed, and the waller is connected to the top of the seat piles. Coping is placed on the top of the seat piles, and the seat piles are driven into the ground. The tiebacks are installed. Collar is connected to the top of the seat piles and the coping is placed on the top of the seat piles. When we talk about the advantages which it serves, so it can be installed in the variety of soil conditions. They can be installed in the confined spaces. They have a high load bearing capacity and relatively quick and easy to install. It also have some disadvantages like it is very expensive to install, require the regular maintenance and inspection. So that also require the manpower, lead to the increase in cost in one way or the other, and susceptible to corrosion. So the corrosion resistance work need to be also be performed. So it is also one of the part of the maintenance which need to be served in order to protect and extend the life of this section. Now, the benefit of the anchor bulkhead. So, anchor bulkhead have the number of benefits like they can be installed in the variety of soil condition. Okay, so this has been great. They can be installed in the confined spaces. They have a high load bearing capacity and they are relatively quick and easy to install. So the disadvantage also already read, so I will skip this. Applications in the waterfront, river bank stabilization, highway and railway construction, land reclamation also read. When we talk about the history, the anchor bulkhead have been used for the 100 years. The first anchor bulkhead used in the 19th century to protect the coastline of the Europe, North America. The anchor bulkhead also used extensively in the Panama Canal early 20th century. The types of tieback system when we talk about the passive and active are the two types of tieback system. So the passive tieback rely on the friction between the tieback and the soil to resist the lateral pressure from the soil. The active tieback are rely on the tension in the tieback to resist the lateral pressure from the soil. Okay, well and good. Now, the design procedure of anchor bulkhead. So, the first of all, the site investigation has been taken, and and the engineer will investigate to determine the soil condition at the site. The structural analysis performed. The structural engineer will perform a structural analysis to determine the load that will be applied to the bulk head. The design of the seat pile wall. A structural engineer will design the seat pile wall to resist the lateral pressure from the soil and the surcharge load. The design of the tieback system, the structural engineer will the soil anchor seat pile, wall and the ground. The preparation of site also takes place by leveling the ground surface. Okay. Now, the construction process for the anchor bulkhead. So it will be processed in the four steps like First of all, the preparation takes place, then the driving of seed pile walls. When we prepare the site by cleaning the area of the debris, leveling the ground, afterward drive the seed pile wall into the ground with the help of the vibratory hammer or the hydraulic hammer. Afterward, the installation of tie bracket takes place, in which the variety of method has been used, like the driving and the grouting or the jetting. Then the construction and coping processes takes place. The top of the seed piles and the coping are placed on the top of the seed piles in order for its installation. When we talk about some more points, the driving of seed piles, the seed piles are driven into the ground using the vibratory hammer or the hydraulic hammer, and the tieback installed using the variety of methods such as the drilling or grouting or jetting. So these are the same points which have been already mentioned. Pile driving test. When we talk about the pile driving test are performed to ensure that the seed piles are driven to the correct depth and they are properly embedded into the soil. The tieback and load system, the tieback load tests are performed to ensure the tieback and can withstand the design load. The welding inspections are performed to ensure that the welds between the seed pile and the waller are sound. Now, when we talk about cost, whether the cost is justifiable or is because anything we do, the cost need to be justified. If cost is too high or not easily achievable to do the construction work, so we will avoid that. So the cost of the anchored bulkheads varies depending on the number of factors, including the size of the bulkhead, the site, soil condition, and the depth of the water. The construction of anchor bulkhead can disrupt the marine ecosystem and can lead to the loss of habitat for the fish and the other wildlife. The anchor bulkhead can also reflect the waves and the currents, which can erode the beaches and damage the coastal ecosystem. Now, the quality control and the testing of the anchor bulkhead, when we talk about, so the quality control and testing is important part of construction of anchor bulkhead. The following tests are typically performed to ensure the bulkhead construction correctly. That is the pile driving, tie break load test, and the welding inspection. So the details has been mentioned here. You can go across if needed. And these are the extra point, not the part of the core syllabus, but I will try to discuss. The environmental impact of anchor bulkhead. Anchor bulkhead can have the negative impact on the environment. The construction of anchor bulkhead can disrupt the marine ecosystem and can lead to the loss of the habitat for fish and other wildlife. The anchor bulkhead can also reflect the wave and the current, which can erode the beaches and the drainage and the coast ecosystem. When we talk about the some case study over there, this is used. So the Palama Canal was constructed in the early 20th century. The anchor bulkheads were used to support the canal wall. The anchor bulkheads are at the Panama Canal are some of the largest and most complex anchor bulkhead in the world. Talking about the second case, like the Golden Gate Bridge. The Golden Gate Bridge are constructed in the 1930s. The anchor bulkheads were used to support the approach ramps of the bridge, and the anchor bulkheads at the Golden Gate Bridge are the some of the most iconic anchored bulkhead in the world. When we talk about the third case, like the Hoover Dam was constructed in 1930s. Anchor bulkheads were used to support the dam abutment, and the anchor bulkheads at the Hoover Dam are the some of the most important anchor bulkhead in the world. Now, concluding this section, the anchor bulkhead can be installed in the variety of soil conditions, and the anchor bulkheads are versatile and effective in retaining wall solutions. They can be used for the variety of applications can be installed in the variety of soil condition. However, it is important to note that the anchor bulkhead can be expensive to install and require the regular maintenance and inspection. Now, we talk about the cantilever seat piles. What do we mean by the cantilever seat piles? Okay, okay, give me some minute. Okay, let's see. Okay, give me a minute. I have to switch on the charging. Okay, see, we are talking about the cantilever seat piles. So, what do we mean by and what are our understanding regarding the same? We will look into that. So, the cantilever seat piles are type of retaining wall that are used to retain the soil and provide a support for the structure. The cantilever seat piles are typically made of steel or concrete. They are driven into the ground to a depth below the retained soil. The seed piles are then connected to each other to form a wall. And and when we go across, we will able to find that the cantilever seed piles are used for the variety of applications, like in the waterfront structure, as the anchor bulkhead also serve the purpose, river bank stabilization, highway and railway constructions, land reclamation, as well as excavation support. At all places, cantilever seed pile walls could also be used. Anchor bulkheads are also used, but this is also. When we talk about the components, its components are also the seat piles, bollards, copings, okay? And the design of cantilever seat pile walls depend on the number of factors like the type of soil, height of walls, or child loads on the walls. And the construction of cantilever seat piles was typically involves some of the steps like the seat piles are driven into the ground, waller is connected to the top of the seat piles and the coping is placed on the top of the seat piles. When we talk about the advantages, they can be installed in the variety of soil condition. They can be relatively quick and easy to install. They have a high load bearing capacity and do not require the tieback or the anchor system. The cantilever seat piles also have some disadvantages like they are not suitable for the applications. All applications they are expensive to install and susceptible to corrosion. This is also seen the region with the anchor bulkheads. Now, when we talk about the application, we have gone across with this application. The cantilever seat piles was are the versatile and effective retaining wall solution. They can be used in a variety of applications and can be installed in a variety of soil conditions. However, it is important to note that the cantilever seat pile walls can be expensive to install and require a regular maintenance and inspection. Now, when we talk about the types, when we talk about the types of the cantilever seat pile walls, so the steel seat pile walls are there. The steel seat pile walls are the most common type of cantilever seat piles and the concrete seat piles are also there. The concrete seat piles are the less common than the steel seat piles, but they are often used in the application when the durability is important because it has the long life. Talking about the design, the site investigations takes place, and after that the design of seat piles has been performed. The constructions of design of seat pile wall takes place by the design engineers considering the soil, lateral earth pressure from the soil and the surcharge load. The constructions drawings takes place. Engineer will prepare the construction drawing and show the layout of the bulkhead and detail of the construction. The construction of the cantilever seat pile wall, the preparation of site, installation of seat pile, and the construction of wall and coping takes place. The quality control and testing of the cantilever seat piles first takes place afterward. In this, it is very important to perform the quality control and the testing during the construction of a cantilever seat pile wall to ensure that the bulkhead is built to design the specifications. Some of the quality control testing procedure that are typically performed include the inspection of the seat piles for the defect, testing of the seat piles to ensure that they are properly driven, and the testing of the water and coping to ensure that they are properly installed. When we talk about the cost of the cantilever seat piles was the cost of the cantilever seat pile was depend on the number of factors like the size of the wall, type of the soil, and the complexity of design. The cantilever seat pile walls can be expensive to install, but they are durable and the long-lasting solutions for the people. When we talk about the environmental impact of the cantilever seat pile walls, the cantilever seat pile walls can have the negative impact on the environment. Cantilever seat pile walls can alter the natural shoreline and can disturb the habitat of the marine life, but it is important carefully consider the environmental impact of the cantilever seat pile wall before the construction of that. Case study, the when we take the case study, the first is the port of Los Angeles. The port of Los Angeles is one of the busiest port in the world, and the cantilever seat pile are used to support the piers and the docks at the port of the Los Angeles, and the cantilever seat piles at the port of the Los Angeles are some of the largest and the most complex cantilever seat piles in the world. Talking about the second case study, Hudson River Park. The Hudson River Park is the water park in the New York City. The cantilever seat pile walls are used to support the park's upland and protect the park from flooding. The cantilever seat piles at the Hudson River's Park are some of the most important iconic cantilever seat pile in the world. Taking the third, like the Three Gallons dams, the Three Gallons dam is the largest hydroelectric dam in the world, and the cantilever seat piles were used to support the dam abutments. These cantilever seat piles was at the Three Gallons dams, each one of the its own type, which had not been able to see in general. Now, talk about the benefits of the seat pile posts. So, they can be installed in the variety of soil conditions. They are relatively quick and easy to install, and high load carrying capacity do not require any tie backs or anchors. Talking about disadvantages, not suitable for application, expensive to install, and can be susceptible from corrosion. Concluding remark for this section is like the cantilever seat piles walls are versatile and effective in retaining the wall solution. They can be used in a variety of applications and can be installed in the variety of soil conditions. However, it is very important to understand that the cantilever seat piles walls can be expensive to install and require the regular maintenance and inspection. Now, talk about the lateral earth pressure braced seat pile wall. So we will move into this section. We will move quickly because we have to finish this section before the end of the today's session. Okay. Okay. So we are over here the lateral earth pressure braced sheet pile wall. The lateral earth pressure, the braced sheet pile walls are the type of retaining wall that is used to support the excavation and retain the soil. The wall are made up of steel sheet piles that are driven into the ground and then braced with the studs and wallers. The studs and wallers help to distribute the load by the lateral earth pressure across the wall. And when we talk about the lateral earth pressure, braced sheet pile wall are used in a variety of applications like deep excavation, tunneling, waterfront structures, slope stabilization, and land reclamation. The component of the lateral earth pressure braced sheet pile walls, the main component of the lateral earth pressure braced sheet pile walls are the sheet pile itself. The sheet piles are the vertical wall that retain the soil, and the second component when we talk about is the struts. The struts are the horizontal beam that brace the sheet pile. Talking about wallers, the wallers are the horizontal beam that connect the studs to the sheet piles. Now you see the design of lateral earth pressure. Okay, so design of lateral earth pressure based sheet pile walls. The design of the lateral earth pressure based sheet pile walls is a complex process that should be performed by the qualified person and which include the some of the steps like the site investigation, then the design of sheet pile walls, and afterward the design of bracing system and then construction drawing. Construction of lateral earth pressure braced sheet pile walls require the preparing of site, afterward the installation of sheet piles takes place, and the installation of bracing system then followed by that. Moving to the advantages of the lateral earth pressure braced sheet pile walls, they can be installed in the different type of soil and can support the deep excavation. They are relatively quick and easy to install, and they are high load bearing capacity. Talking about disadvantages of the lateral earth pressure based sheet pile walls, they can be expensive to install, require regular maintenance and inspection, and can be susceptible to corrosion as well. Now, talking about applications of the lateral earth pressure sheet pile walls, so it could be it could be used in the waterfront constructions. Okay, give me a minute. There may be a network problem at this point of time. Hello, am I audible? Hello, oh, hello. Hello. Wait for some time. Hello everyone. Wait for some time. There is a network error. Hello. Hello. Am I audible? Hello. Okay. I think so. Okay. Okay. So let's start. So due to some network problem, we get disconnected. So that's why the problem arises. So okay, I will take it from here. There is a small sections left. Okay, so my presentation is visible to everyone. I think so, yes. Okay. So we are talking about the application. We are talking about the application of the lateral earth pressure rest sheet pile walls. So we will finish it quickly, very quickly. So the application of the lateral earth pressure rest sheet pile walls in the deep excavation, tunneling, waterfront construction, slope stabilization, and land reclamation. Okay. So see the important to follow all the safety guideline when working in a lateral earth pressure based sheet pile process. Okay, because the safety construction is also required to follow, otherwise maybe during this work some accidents could take place. So we need to take care of about that. So the always wear the proper personal protective equipment such as the hard hat, safety glasses, or and the safety boots. Be aware of your surroundings and be careful not to trip over or fall into the excavation. Do not operate any machinery without the proper training. Follow the instruction of the engineer or the other qualified person. Concluding these sections, like the lateral earth pressure based sheet pile walls, are the versatile and effective. retaining wall solution. They can be used in a variety of applications and can be installed in the variety of soil conditions. However, it is important to note that the lateral earth pressure based seed pile walls can be expensive to install and require the regular maintenance and inspection. Talking about the lateral earth pressure based seed pile walls, again with some other perspective in very quick manner. So starting with definition, the definition of lateral earth pressure. The lateral earth pressure is the horizontal force exerted by the soil or the other material against the retaining structure. It arises due to the natural tendency of soil to move and redistribute when subjected to the external loads. Talking about its importance in civil engineering, the lateral earth pressure is a crucial in civil engineering and as it directly impacts the design and stability of the retaining structures like walls, foundation, and embankments. Understanding and managing the lateral earth pressure is the essential for the construction safe and durable infrastructure. Overview of the present section. The present sections will cover the fundamental of the lateral earth pressure, various theories related to it and the design consideration, type of retaining structure and a specific focus on the breast sheet pile first. The two primary theory used in understanding the lateral earth pressure is the Coulomb earth pressure theory and the Rankine earth pressure theory. This theory provides the foundation for the design. This theory provide the foundation for the designers in the retaining structure design. Talking about the Coulomb earth pressure theory, Coulomb theory is based on the concept of the active and the passive earth pressure, which depend on the angle of internal friction of soil. It helps engineers to calculate the lateral forces acting on the retaining wall. The Rankine earth pressure theory, talking about the Rankine earth pressure theory takes into the account of both angle of internal friction between the soil and the retaining structure. It provides the more accurate predictions of the lateral earth pressure and the wall stability. Okay. Now, the type of retaining structure. The retaining structures are the engineering solution used to support the soil or the other material to prevent them from collapsing or sliding. They are essential in the various construction and infrastructure projects. When we compare the breast seat pile walls with the other retaining walls, the breast seat pile walls are distinguished from the other retaining structure by their use of the seat piles combination with the bracing system. Unlike gravity walls or the cantilever walls, breast seat pile walls rely on the external bracing to resist the lateral earth pressure. Talking about the common application of the breast seat pile walls, the breast seat pile walls are commonly used in the waterfront structure to control the erosion, protect against the flooding, and provide a stability for the excavation and foundation. Talking about the key component of the bridge seat pile walls, the bridge seat piles walls are consist of the seat piles that act as a primary structural element, and these seat piles are typically made up of steel and they form the core of the wall. Talking about the bracing system provides the lateral support to the seat piles. They include valves, struts, and tiebacks or anchor which help distribute and resist the lateral forces. Tieback and anchors are the crucial component that anchor the wall to the stable soil or rock. They prevent the overturning and sliding of the seat piles. Talking about the facing materials often made up of the concrete, timber, or steel provide the protection and aesthetic component to the wall surface in a real sense. Design consideration, talking about the design consideration, the facing factors including design are the design consideration include the soil property, wall height, external loads, groundwater condition, and the project specific requirements. Load calculation and structural analysis, the engineers calculate the sorry, engineers calculate the loads that wall must resist, including the lateral earth pressure and the water pressure and any additional external loads. Talking about the soil mechanics aspects like the geotechnical aspects, so the understanding the soil property such as the bearing capacity and the settlement characteristics is essential for designing the stable braced seed pile wall. Okay. Moving ahead, the lateral earth pressure distribution, the explanation of the lateral earth pressure distribution, lateral earth pressure variation along the height of the wall. So this include the active earth pressure pushing the wall outwards and the passive earth pressure moving the wall inward. And at the rest pressure, no movement takes place and the distribution depend on the factors like the soil property and the wall friction. Moving ahead, the braced seat pile was the design process of the braced seat pile was the design braced seat pile was involves selecting the appropriate seat pile type and the size, determining the bracing arrangement and addressing the drainage and the seepage control to ensure the wall stability. The types of bracing system introducing the bracing system provide the essential lateral stability to the brace seat pile walls. They include cantilever bracing studs and the tie backs and the anchored bracing, each with its advantages and applications. Talking about the case study, showcase the real world example and the best seat pile wall projects. Case study provide the practical insight into the application of the best seat pile walls in the various construction scenarios. Talking about the construction and installation, the construction phase of the bridge sheet pile was the construction process involved the phases such as excavation and the sheet pile walls installation, assembly of the bracing system, and backfilling and the proper sequence and the safety measures are also the critical aspects. The safety measures, talking about the safety measures, the safety during the construction include the measures to the project works, prevent accidents, and ensure the integrity of the wall throughout the construction. Case study on the installation process. So the case study illustrates the step-by-step installation process of the bridge sheet pile walls, highlights the specific challenges faced and strategy employed. Monitoring and maintenance. So the importance of monitoring for the structural integrity, regular monitoring is crucial for determining the early sign of distress or instability in the wall. It helps to ensure the long-term structural integrity. The maintenance consideration is also equally important. Talking about the maintenance tasks include the routine inspection, repair of the damaged components and the addressing any drainage issue. A well-maintained wall prolongs its life and reliability. Inspection protocols, talking about the inspection protocols outline the procedure and criteria for accessing the condition of the breast seat pile walls and including the measurements of the anchor, tension, wall alignment. Talking about the environmental considerations, the impact of surroundings, environment, the construction and the presence of the waste seed pile walls can affect the natural environment, including the water flow, vegetation, and the wildlife habitat. Consideration of these impacts is crucial. Erosion control measures sorry, the implementing the erosion control measures such as planting vegetation or installing the sediment barriers can mitigate the environmental impact. Uh, um, of the breast seed pile was the compliance with the environment regulation, the compliance with the local, regional, and national environmental regulation, and obtaining the necessary permits is essential. Talking about the environmental consideration, the safety precaution is equally important because during the construction, the safety measures include providing the proper personal protective equipment to the workers, ensuring the safety, and talking about the long-term safety consideration like the monitoring anchor condition, inspecting bracing system, and addressing the potential hazard like the corrosion or erosion. The compliance with the occupying safety standards. This means the standards guidelines which have been provided by the different institutions need to be followed, and the inspection by the authority need to be takes place from time to time. Okay, talking about the cost consideration, the factor affecting cost, the several factors affect the cost like the seat pile wall projects like including the design complexity, the choice of material, sorry, labor cost, and any required geotechnical investigation. The budget involves the estimating the project overall cost, including the design, material, construction, and the contingencies. Accurate budgeting is essential for the project plan. Talking about the cost benefit analysis, help to evaluate whether the benefit of the construction a breast seat pile was such as the flood protection or stability overweight the project cost over its lifetime. Future trends and innovations. Emerging technology in the breast seat pile was design. Emerging technology may include the use of the advanced material to innovate monitoring system and automation in the construction process. Talking about the sustainable practices, so sustainable practices in the retaining wall design may involve the green wall solution, eco-friendly material, and the designs that minimizes the environmental impact. Ongoing research and the development area may include the improving the wall materials, enhancing the construction method, and optimizing the design for the increased efficiency and sustainability. Moving ahead, concluding the sections with the some of the important like point like it emphasizes the importance of understanding the lateral earth pressure, proper design, construction, monitoring, and environmental consideration, the stress of the significance of the well designed and well maintained breast seat pile wall in ensuring the safety, stability, and the protection of the infrastructure and the environment, encouragement for the further learning, and encouragement for the people who are listening to explore the additional resource to contribute in the learning about the complexity and best seed pile walls. So, okay, with this, I will end up the session for today. Hope you understand all the points, and in the next class we will move to the slope stability. Over there we will understand the stability considerations, and we will solve the problem related to the slope stability of the infinite and finite slope which we have gone across. And the as per given schedule, the next session will be going to be our last session. So in from starting to end, whatever the any doubt will be there in anyone's mind can came over there and ask. I will try to answer those problems. So with this, I will end the today's session. Thank you very much everyone for joining. Thank you very much.